An object from another star slides toward Mars, bright enough to stir old instincts yet met with careful whispers. Inside control rooms, screens glow and clocks advance, but no countdown rolls across the public stage. Earth's telescopes inch toward a glare that will blind them at the moment of peak heat. A meeting happens on a base with few details. A comet gains names and numbers while the story avoids headlines. Stay, and hold a breath with me, because what we learn in the quiet may decide what we see when the glare fades. Listen to the sky first. A small bloom of light, not a star, moves against the fixed patterns we trust. Surveys notice, the Minor Planet Center confirms, and the label clicks into place, C/2025N1, the third interstellar object on record, 3I Atlas. Its path is hyperbolic, its speed remarkable, roughly 61 kilometers per second relative to the Sun, a momentum earned in some other neighborhood and carried here. It is not bound to our star. It is a visitor passing through. This alone should feel cinematic, and yet the public tone is subdued. Blog posts appear, updates arrive in neat paragraphs, and then the signal thins into a careful hush. Consider the geometry that will shape the next chapter. The object crosses near Mars with a closest approach of about 30 million kilometers, about 0.19 astronomical units. Not a threat, not even close, but close enough to be measured with purpose by orbiters that can pivot for a better look. Later in October, the path dips to a nearest distance from the Sun near 1.4 astronomical units, a perihelion that should raise activity and peel back the chemistry. That is when Earth stares too near the Sun to see. Telescopes protect themselves. The sky turns into a sheet of white noise. The timing is an irony that writes itself. Just as the physics gets interesting, the public view dissolves. If this were a different kind of story, we would cut to a live countdown. Instead, we are handed receipts and asked to read between the lines. The discovery chain is public. The ephemerides are public. The preprint on chemistry is public. The silence that people feel is not the absence of data. It is the absence of spectacle. Maximum celestial drama, minimum institutional noise. That is the paradox. It does not require a villain. It requires a patient eye and a taste for evidence that creeps rather than shouts. There is another kind of quiet that lives at the edge of coincidence. People notice headlines about a large meeting at a military base and ask the most human question, do these timelines touch? The answer we can defend is simple. There is no public evidence that they do. The meeting exists as a line of text, the comet exists as a line of light, and the two lines cross only on a calendar. Still, the overlap adds an eerie color to a month already full of eerie colors, a red planet, a bright visitor, and a narrowing window of sight. You can feel the story offering you a fork. One path turns the quiet into a verdict. Another keeps the quiet as texture and turns to the numbers that we can test. We choose the second path. What is known stands on one side of the frame. There is a designation, there is a speed, there is a trajectory, there is a schedule for when the view improves again. On the other side, we place the questions that keep a late-night audience awake. Why is carbon dioxide so strong in the early spectra? What happens when the heatwave moves inward? Will Mars-based instruments see a steady rise, or will they catch a pulse that hints at crust and pockets? When Earth returns to clear angles in December, will the object's push through space match what the outgassing can explain? The craft of this film will be to hold those two sides together without letting them bleed into each other. Known against unknown, receipts against rumor, a patient oddity against a tired conspiracy. We will cut to facts with clarity, and we will open doors with canned caution. One possibility is that this is a natural comet with unusual chemistry born of a colder or carbon-rich nursery. A competing view suggests layered ices that vent fizz before steam, and that the water voice grows later. It remains uncertain whether the path through Mars, then Venus, then Earth, then Jupiter, is anything more than chance amplified by where our surveys look most. Evidence is limited, but one inference is that the lack of press theatre reflects process and review, not suppression. So we begin in the key of restraint. The object is real, the speed is real. The geometry is unkind to Earth-based eyes at exactly the moment we crave detail. The silence is not empty. It is filled with scheduled looks from Mars and with a coming return to sight. If you hold the paradox now, the next parts will show how to read the sky that sometimes hides itself, and how to keep wonder bright without letting imagination outrun the math. Begin with the paper trail that anyone can follow. A survey camera scans the sky and flags a point that moves against the patient grid of background stars. Observers confirm the motion on subsequent nights. Coordinates and times enter a shared database. The Minor Planet Center issues a circular that includes provisional designations, observation sites, and early orbital elements. Within a day, enough data arrives to fit a path that does not close around the Sunday eccentricity greater than 1, a textbook marker of an interstellar origin. A visitor is now more than a rumor. It is a record you can open on a screen. From there, the numbers accrete into meaning. The designation C/2025, N1, tells you a season and a nature. The C marks active coma, gas and dust in play. The year stamps the discovery window. The letter and number index the half-month and the order in that span. The label 3I, Atlas, adds the status that captures the imagination, third of its kind, on record. The survey name anchors human credit and institutional memory. None. Toe of this requires trust in personalities. It asks only that you accept that telescopes take images and that time-stamped measurements can be combined to draw a curve. Open an ephemeris generator and the curve becomes a schedule. Position in right ascension and declination for any time of night. Distance from the sun and from the observer. Solar elongation that warns when the line of sight nears the glare. Phase angle that hints at how dust will scatter light toward us. These columns look cold until you imagine them as a travel itinerary. The numbers carry you to a date when the object passes near the orbit of Mars at about 30 million kilometers. The numbers then push you forward to a late October moment when the object is nearest the Sun, near 1.4 astronomical units. Then they remove you from the scene for weeks, because the elongation shrinks and Earth must look away. The next breadcrumb is brightness, which is a slippery witness. Hubble can constrain the size of the unresolved core by modeling how much material is needed to produce the observed coma. That is how we arrive at an upper limit near 5.6 kilometers, with room on the smaller side if reflectivity and dust yield are different than assumed. The range is wide because the core is still a point inside a glow, but even as a range it matters. A small nucleus would respond more to gas jets, a larger one would carry more inertia. The difference will show itself when we compare observed thrust with inferred mass later on. Spectra turn the glow into chemistry. The Webb observations place a thumb on the scale with an unusual ratio. Carbon dioxide appears far stronger than water in the coma. A reported ratio near 8:1 flips expectations built on local comets where water usually leads. That does not prove exotic intent. It points instead to alien weather in a birth disk, or to a layered body where carbon dioxide nearer the surface wakes first. One possibility is that the deeper water will rise in prominence after perihelion, once heat has crept inward. A competing view suggests a fundamentally carbon-rich body that never gives water the loudest voice. It remains uncertain whether the ratio will change, but we now have a prediction to test once observations resume from Earth. We can also use the record to define what is not happening. There is no credible hazard to Earth in the current geometry. Closest approach to our planet sits far beyond comfortable headlines. The Mars pass at about 0.19. Astronomical units is close, in astronomical terms, and distant in human terms. The ephemeris lets you verify these distances, and it does not care about mood or rumor. Known sits cleanly on one side of the table. Unknown sits on the other side and invites careful questions. The breadcrumb method changes how the silence feels. Once you have the circulars, the observing logs, the ephemerides, and a preprint or two, the story sounds less like secrecy and more like process. Agencies publish in dry language because that is how large teams avoid errors. Blogs and short updates feel flat because they speak to many audiences at once. Evidence is limited, but one inference is that the tone reflects institutional caution, not a decision to hide. A minority view holds that the restraint is itself a signal, yet that claim remains untested. The bread on the table tastes simple, and it is enough to get to the next course. This is the through line so far. Follow receipts, then build questions that can face a calendar. The object is interstellar. The speed is consistent with that origin. The geometry creates a blind spell at the very moment when heat should stir the interior. Chemistry is odd, but odd within the space of natural explanations. The next move is to examine how a survey catch becomes a confirmed track, and how certainty is earned step by step rather than declared in a single leap. Begin with a sky full of noise that hides a single moving point. Survey cameras sweep the darkness with a rhythm set by automation and by weather. Each exposure freezes a pattern of stars that do not budge from night to night. The pipeline subtracts one frame from the next and looks for anything that shifts. The candidate appears as a soft bead that slides a little between frames. A human checks the machine. The blink test plays 2 images as a flipbook. The bead hops while the stars stay still. A note goes into the log. Coordinates and times flow into the report that rides the network to the gatekeeper of small bodies. The Minor Planet Center speaks in brief lines that carry weight. A circular lists stations, timestamps, and measured positions. The first orbit is a sketch that wants more paint. Observers around the world answer the call for follow-up. Small professional telescopes and skilled amateurs push to the same spot of sky. They measure again and again. Each new point is a nail that fastens the curve. You can watch the uncertainty shrink. The cloud of possible paths tightens as if a hand were closing around a thread. Orbit fitting turns geometry into story. The solver tries closed ellipses first because most small bodies belong to the Sunday. The math refuses to settle there. The best fit wants an open branch. Eccentricity greater than 1. Inclination near the ecliptic but retrograde. A speed at infinity that makes sense for a traveler that fell toward us from interstellar distances. This is the moment when a whisper becomes a sentence. You can call it an interstellar object with a straight face, because the numbers now insist on it. Certainty grows in layers. Astrometry anchors the path. Photometry sets the brightness scale. The pipeline screens out false motion from atmosphere and from tracking errors. Plates are calibrated to catalogs so that pixels map cleanly to the sky. When a point passes near a field star, the reduction flags the risk of contamination. Observers adjust aperture sizes to isolate the nucleus, region within the coma. They repeat on later nights to smooth out twinkles from seeing. None of this is dramatic to watch. All of it is essential to the final confidence. Sometimes the past helps the present. Recovery searchers trawl old images to see if the object was caught by accident before discovery night. A match turns up in an archive. A streak sits where the solver predicts it should. That single line from months ago stretches the time baseline and snaps the orbit into even sharper focus. With more span, the uncertainties in distance and speed shrink. This is how a few days of data becomes a stable trajectory. A longer ruler gives a truer measure. The survey net and the confirmation dance also carry biases that matter. Telescopes look most often near the plane where planets move. That is where asteroids live. That is where comets cross often enough to reward the search. We are more likely to spot an interstellar traveler if it skims that same plane. The shape of our attention shapes what we find. A selection effect does not change the truth of one orbit. It does change how we feel about patterns. Later, we will test the urge to see choreography where chance and attention might be enough. Once the early arc is set, an ephemeris becomes a contract with the sky. JPL Horizons and other services publish positions for the days ahead. Follow-up teams aim based on those numbers. Success feeds back into the model. A clean pick on a predicted night proves that the math is capturing the real motion. A missed pick signals either weather or a need to tweak parameters. This loop builds trust better than any press release. Plot predictions. Observe, compare, correct, repeat. The curve becomes a path you can plan around. Precision improves further when the comet brightens. As activity grows, the coma swells and the centroid can drift as jets push dust unevenly. Good practice then is to keep measurement apertures consistent and to model the point spread carefully. The goal is to maintain apples-to-apples positions over many nights. In parallel, spectroscopic teams target windows with good solar elongation. A single high-quality spectrum can anchor a chemical interpretation for a month. Together, position and composition become the twin rails of the story. The pipeline has one more gift. It makes limits honest. When the orbit solution says that the closest approach to Mars is about 30 million kilometers, you can accept that number because it rests on hundreds of small acts of care. When the same solution says that Earth will not be in harm's way, you can lower your shoulders and breathe. When the timeline shows that Earth will face a period of glare near perihelion, you can accept the coming gap as geometry, not as plot. At the far end of this process stands a question that numbers cannot answer alone. How large is the heart inside the glow? Photometry suggests bounds, but not a direct size. For that, we lean on instruments that can place upper limits with better control of scattered light and dust yield. The next part steps into that room. We will take the unresolved core and treat it as a source of momentum, then ask what its possible sizes imply for how strongly gas can steer it when the sun turns up the heat. Begin by picturing the coma as a lantern and the nucleus as a coal hidden inside the glow. We do not see the coal directly. We infer its presence from the light that surrounds it, and from how that light grows as the sun squeezes more vapor from the surface. Hubble's measurements help by pinning a ceiling on the size. The unresolved core must be smaller than a few kilometers across, with an often cited upper limit near 5.6. It could also be far smaller, perhaps hundreds of meters, if the surface reflects more than assumed, or if the dust output per unit area is higher. That range is not a trivial detail. It sets the mass scale, and mass governs how stubborn the traveler will be when gas tries to push it. A body that spans kilometers carries a great deal of inertia. Gas jets will still produce thrust, but the same push will create a smaller acceleration than it would on a lighter object. A nucleus that is only a few hundred meters across sits at the other end of the response curve. It can yaw and drift more readily, as vents open and close with rotation and heat. This is where the language of rockets enters a quiet astronomy story. Outgassing ejects mass. Ejected mass carries momentum. The reaction changes the motion of the source. The magnitude of that change depends both on the speed of the escaping gas and on the mass of the body that launches it. Momentum conservation is a simple rule that becomes a delicate diagnostic when the forces are small and the time spans are long. Brightness is a slippery stand-in for size because dust and gas production muddle the light. Two comets with the same nucleus radius can present very different comae if one sheds dust efficiently and the other clings to its grains. That is why Hubble's upper limit is framed as an upper limit. It is a line in the sand that says the core is not larger than this value, given reasonable assumptions about reflectivity and scattering. It does not declare the true size. For that, we wait on dynamics. After perihelion, when Earth regains a clear sightline, a careful comparison between the measured non-gravitational accelerations and the observed gas production offers a way to infer mass. If the push implied by the vented material is small yet the motion shifts strongly, then the nucleus is light. If the push is strong yet the motion remains steady, then the nucleus is heavy. Shape also lurks inside the question of size. A sphere is a rare luxury in small bodies. Many nuclei are elongated or lobed, with irregular surfaces that funnel sunlight into preferred patches. Active areas may cluster along fractures or around pits. When those areas face the sun, vents open and thrust vectors line up in repeatable ways. The rotation state then becomes critical. A slow tumble can smear thrust in all directions and hide coherent patterns. A stable spin can lock jets into rhythms that repeat with each turn. Size couples to shape through tensile strength and through the propensity to fracture. Smaller bodies can be rubble piles held together by weak gravity and by frozen cements. Larger bodies can hold coherent faces that crack along scarps when internal pressures rise. Thermal physics ties the bow on the size problem. Heat does not dive into ice at the speed of light. It crawls. The skin warms quickly. The interior lags. A thin body can equilibrate sooner, and deeper layers can join the outgassing game near perihelion. A thicker body can keep its heart cold during the same interval. The lag matters for chemistry. If carbon dioxide sits near the surface and water lies deeper, the timing of the water voice will reflect not only composition, but also a length scale. In December, a rise in water bands relative to August could support a layered story. The amplitude of that rise may whisper the distance that heat had to travel. Risk is a separate box. Unfortunately, it is not the box we need to open. The Mars pass at about 30 million kilometers is a scientific opportunity, not a hazard. The mass of the nucleus can influence how dust spreads and whether fragments would persist if a shell fails, but the geometry does not place either Mars or Earth in a path that threatens missions or people. That clarity lets us consider size in a spirit of curiosity rather than fear. We ask how large is the heart because the answer will shape the thrust signature, not because larger means danger. The most honest posture at this stage is to hold a range and to outline tests. Hubble tells us the nucleus does not exceed a modest few kilometers across. Photometry says it could be much smaller. Spectra announce that carbon dioxide is loud already. The next decisive step is to translate gas into push and push into mass through precise positions over many nights. That path leads straight to chemistry. If size sets how resistant the body is to thrust, then composition decides which jets fire first, and how the pattern of pushes evolves as sunlight penetrates. Begin with a prism and a ghost. The prism belongs to a space telescope that stares into cold light. The ghost is the coma that wraps an unseen heart. When the James Webb instruments turn to 3i Atlas, the glow stops being only brightness. It becomes a barcode of the molecules set free by sunlight. Bands appear at familiar wavelengths. Their heights say who is speaking and how loudly. In this case, an unexpected voice leads. Carbon dioxide, strong and insistent, rises far above water. A reported ratio near 8:1 turns a quiet spectrograph into a plot that feels like a plot twist. For most comets in our neighborhood, water is the headline gas. It wakes early and plentiful, then brings along carbon monoxide and carbon dioxide in supporting roles. Here the order is reversed. The spectrum reads like a pantry that belongs to a different kitchen. Carbon monoxide is present. Carbonyl sulfide peeks in as a trace. But the bars that dominate are from carbon dioxide. That does not prove anything exotic by itself. It does force us to ask what kind of nursery makes ice that vents this way. One possibility is a birth zone that sat in colder reaches of a foreign disk, where water condensed deeper than carbon dioxide. A competing view suggests that layering within the nucleus hides water below a crust that is rich in carbon dioxide. It remains uncertain whether either picture will win. The only judge that matters is the way the lines change with time and with heat. The beauty of spectra is that they are both poetry and meter. They sing and they count. If carbon dioxide is rising because it sits near the skin, then as the thermal wave creeps inward, water should climb. Not all at once, not like a switch, more like a slow chorus that grows verse by verse. If the body is fundamentally poor in water, then the chorus may never outrun the soloist. December will give us the next stanza. Mars may even offer a bridge during the early October window if its instruments are lucky with signal and geometry. Watch for faint waterlines gaining strength relative to the late summer baseline. Watch for carbonyl sulfide to waver if pockets open and close. Each change is a clue. Each non-change is also a clue. Chemistry is also a map of pressure and structure. When gas escapes, it chooses the easiest path. Fractures and pits act as vents. If the nucleus has patchy composition, then rotation will modulate which patch faces the sunday. That sets a rhythm in the outgassing. Spectral lines that throb on a repeatable period would be the fingerprint of a surface with hot spots and quiet zones. A period that drifts would hint at torque from jets, or at structural changes as crust breaks and reforms. Evidence is limited, but one inference is that time series spectra, even at coarse cadence, can turn the coma into a clock that tells us about the spin and the vents. There is a temptation to read too much into one night of data. Resist that urge. Webb offered a snapshot in late August. It is a high-quality snapshot. It anchors the story. It does not finish the story. In comet physics, context is everything. Distance from the sun matters. Distance from the observer matters. Phase angle matters. Heating lags matter. Without a sequence, a single ratio can mislead. A minority view holds that such an extreme ratio already implies something beyond standard chemistry. That claim should be stored on a shelf until new lines either echo the first measure or transform it. Think also about dust and its quiet role in this tale. Dust scatters sunlight and carries sublimated ices away from the nucleus. Large grains do not leave as easily as small ones. Grain size distributions can be read in the shape of the continuum beneath the lines. If a surge of large grains appears, the reflectant slope can tilt. That changes how bright the coma looks for the same amount of gas. It also sets the stage for the tail geometry that can play tricks with our eyes. This is why chemistry should be paired with careful photometry. The goal is to separate what the gas says from what the dust makes us feel. There is comfort in the fact that odd does not mean unsafe. The carbon dioxide dominance is a curiosity that teaches us about planetary kitchens beyond our own. It does not add hazard to a trajectory that has already been tested for risk. The excitement here lives in the chance to watch a body that does not follow the usual recipe and to let its behavior refine our models of how planets and comets form around other suns. If the lines keep their strange order, we will learn about chemistry that is alien in the literal sense. If the lines swap places after perihelion, we will learn about layers and lags inside a small world. The next move is to set chemistry beside geometry. Composition speaks to what is loaded inside the nucleus. Path and angles speak to what our instruments can see and when. A strong ratio can only be tracked if the target can be pointed to without risking hardware. As October advances, our own view will narrow and then disappear. That is not drama. That is the alignment of Sun and Earth and object, which means our next part must follow the orbit as it threads near Mars and toward a glare that will force us to wait. Begin with a map that breathes. The Sun sits at the center, a pale lantern in a dark room. The planets sweep along thin tracks that glitter like chalk under a lamp. A single bead enters the frame from afar, not bound, moving with its own intentless resolve. It crosses the lanes on a line that leans only a few degrees from the crowded plane of traffic. The camera lowers toward Mars, a rust coin lit on one edge. The bead glides past at about 30 million kilometers. Astronomers call that roughly 0.19 astronomical units. In human terms, it is a respectful distance. In scientific terms, it is a gift. It is close enough for orbiters to taste the light of the coma and to watch the dust respond to angles. Watch the geometry turn like a lock dial. October begins with a narrow window in which Mars has the best seat in the house. Instruments on the Trace Gas Orbiter and Mars Express can stare away from the Sun more easily than Earth assets that are hustling toward telescope safety limits. The bead moves on. By late October, the path reaches a nearest point to the Sun, near 1.4 astronomical units. That is not a dive. It is a deliberate brush with warmth. Physics will ask hard questions of the nucleus then. Which ices lead? Which fractures open? Which jets find rhythm? Earth will miss most of that conversation. Solar glare will wash the stage. The sky will refuse a direct look. The path after perihelion reads like a list that suggests a plan, even if the plan is only in our minds. The bead will arc inside the orbit of Mars and sweep toward a region that places Venus and Earth on later pages of the calendar. Jupiter waits farther out on a date that will belong to spring. That sequence is the kind of thing that pulls eyes into patterns. One possibility is that it is simply what you get when a fast object from a random direction happens to arrive in a plane where surveys look the most. A competing view suggests that the near coplanar alignment deserves extra attention, because most random arrivals would cut at steeper angles. It remains uncertain whether selection effects fully account for the comfortable feel of this route. The only honest move is to treat the sequence as an invitation to measure, not as evidence of will. Angles control what we can learn in each chapter. Near Mars, the phase geometry can favor forward scattering from dust grains, which brightens the coma from that vantage. A week later, the angles change, and the dust tells a different story. At perihelion, Earth angles are poor, so coronagraphs will become the sketch artists that work in outline rather than in detail. As the object moves away from the Sun after late October, Earth gains angular room, solar elongation grows, pointing constraints relax. December becomes a place where astrometry can resume with precision and where spectrographs can check whether water has found a louder register. There is a humility in accepting a sky that will not face us when we most want it. A minority view holds that timing this clean is suspicious. That claim rests on mood and on the hunger for narrative alignment. The counter-argument is in the tables, in the simple way that a moving point crosses a plane where most of our instruments look by design. The bead does not know our calendars. We are the ones who keep score. We are also the ones who choose how to respond to a gap in visibility. We can rush to fill it with heat, or we can use it as a frame that heightens the value of the data that does arrive, and that sets clear tests for the moment the glare ends. The Mars chapter is the hinge. If spectra from early October show stable carbon dioxide with a whisper of water that slowly rises, then the layered nucleus idea gains power. If there are spikes that come and go in a matter of hours, then crust failure and pockets deserve more weight. If nothing much changes at all, then we may be meeting a body that is carbon dioxide rich throughout, which is a story of a different birth pantry, rather than of unusual structure. Each of those outcomes will color how we read the path, as it drifts past Venus and into a December when northern winter observatories open their domes and return to the chase. Threading the planetary needle sounds like choreography. It may be only geometry and attention. Either way, it is beautiful to watch, and it is practical. A path that scrapes the ecliptic gives us more chances to point. It also tempts us to imagine pilots where there are only ices. We will keep the beauty and drop the temptation. We will hold to tests that can fail. When the bead has passed Mars and the Sun, we will check its position against gravity and gas. We will check its spectrum against August. We will check our feelings against the numbers that do not care about our feelings. Through-line reorientation. Known sits on one side as path and dates, unknown sits on the other as cause and intent, and our task is to let measurements carry the story across the gap without letting imagination run ahead. Begin with a wall of light. Late October pulls the object close enough to the Sun in our sky that the safe rule becomes simple. Do not point most telescopes there. Mirrors and detectors that serve us for years are protected by strict angles and by software limits. Observers who have spent months planning now watch the numbers slide below practical elongation, and the feeling is not subtle. It is like losing the sound at the climax of a song. The physics does not stop. The comet still heats. The gases still surge or stall. We just lose the easy way to watch. In that silence, a strange second orchestra begins. Human imagination hates a blank page. Social feeds fill with recycled frames and bold captions. Old images are presented as new. Anti-tail illusions are posted without geometry. Anonymous watermarks promise leaks from instruments that have not even taken data yet. The narrative stretches to cover the gap with whatever material is at hand. It is not villainy. It is a predictable feature of how attention hunts for novelty when the sky itself has chosen to be uncooperative. Glare is not a conspiracy. It is an angle. The Sun scatters light through optics and through thin layers on mirrors. A bright disk just outside the field can flood a detector with stray photons and turn a faint coma into a uniform wash. Even space telescopes have keep-out zones, because sunlight is not only blinding, it is heat that can warp structures and saturate sensors. That is why instruments are built with baffles and shields, and why pointing calendars have holes that look perverse until you remember the engineering that keeps them alive. The comet is not hiding. We are averting our eyes so that they will still work later. There are still ways to listen to the scene during the glare. Solar observatories with coronagraphs carve a dark circle over the Sun and reveal a ring of sky that would otherwise be impossible to view. If the object passes through those fields, we can harvest brightness trends and survival hints. We will not get clean chemistry. We will not trace jet directions with confidence. But we can see if the glow tightens or diffuses. We can see if the light curve jumps in a way that suggests a sudden outburst. These are sketches rather than portraits. They are still useful as placeholders until December opens a wider window. The psychological effect of a blackout is stronger than most schedules can withstand. People are primed by past stories. Oumuamua offered a short, intense window. Tuai Borisov offered a longer one, but with calmer behavior. Now the public waits during the very phase that invites dramatic change. Fragile crusts can fail near peak heating. Non-gravitational thrust can pivot as new vents awaken. If we could watch the whole time, the surprises would arrive as lines on a graph. In a blackout, the same surprises arrive as rumors and as dreams. The difference is not small. A rumor allows any shape. A line allows only one shape. That is why patience is a scientific virtue and a narrative challenge. One possibility is that nothing dramatic happens. The comet brightens modestly, reaches a smooth peak, then begins to fade as it rounds the bend. A competing view imagines a fracture that vents a buried pocket and produces a burst that coronagraphs can barely resolve. It remains uncertain whether the nucleus will shift its rotation during this time. Evidence is limited, but one inference is that a change in the period will announce itself later through a new pattern in the light curve. The glare period is therefore not just empty waiting. It is a box where the system evolves without immediate oversight. When the lid opens, we compare before and after, and the difference tells the tale. If you want a practice that resists the pull of speculation, build a small ledger now. Write down the predictions that each hypothesis makes for December. If the body is layered, water will speak more clearly after the heat wave arrives at depth. If the body is carbon dioxide rich to the core, water will stay faint. If jets have been steady, non-gravitational residuals will match the direction of outgassing. If jets have been chaotic, residuals will require a richer model or will average away. This ledger turns the blackout into a wager with rules. It converts a vacuum into a stage set for tests. There is a final comfort hidden inside the glare. The cosmos does not time its drama for our convenience. We are not owed a live feed. We are offered a problem with a clear boundary. Keep your instruments safe. Let the object cook. Use what solar platforms can safely deliver. Then return with fresh sensors and fresh eyes. The story will be waiting. The numbers will be waiting. The wonder will still be there, not because rumor kept it alive, but because physics never stopped writing. Begin by shifting the vantage point to a red world that circles under thin air. While Earth turns its face away from the sun to protect delicate optics, Mars keeps a steadier gaze. Two workhorse spacecraft become our proxy eyes. The Trace Gas Orbiter, with instruments built to sniff the Martian atmosphere, can point past the planet and sample the light from a foreign coma. Mars Express, veteran of many campaigns, can collect spectra and brightness maps with quiet patience. Between them, a week at the start of October turns into a laboratory that sits closer to the action than any instrument near Earth can manage. Set expectations with care. No camera at Mars will resolve the nucleus. Even at a closest separation near 30 million kilometers, the heart remains a point buried inside glow. What these orbiters can do is time series spectroscopy and disciplined photometry. Nomad and ACS on the Trace Gas Orbiter can read molecular lines as they wax and wane over hours and over days. Omega on Mars Express can build maps of reflected light that reveal how dust scatters at changing angles. Together they can trace whether carbon dioxide holds the microphone, whether water clears its throat, and whether trace species like carbonyl sulfide drift in and out as vents open and close. Why Mars, and why now? Geometry gives us a gift. The planet sits at a phase where instruments can point toward the target without straying into dangerous solar angles. The subtlety is in cadence and in calibration. These instruments were built to stare at Mars. They have routines for calibrating against surface and sky. Pointing at a moving comet asks them to work slightly outside habit. The teams will schedule short stares, repeatable sequences, and careful background subtraction. They will adjust exposure times so that lines do not saturate, and so that faint features stand above noise. It is slow craft. It is the kind of craft that pays dividends when the world waits for a single clean comparison between August and October. The chemistry test is straightforward to state. If the nucleus is layered, then heating should send a thermal wave inward. Carbon dioxide should remain strong because it sits near the skin and needs less heat to leap into gas. Water should grow as depth warms enough for ice to sublimate. One possibility is a gentle rise that becomes obvious only after a week of stacking. A competing view expects sharp pulses, small eruptions that follow cracks in a fragile crust. It remains uncertain which picture will win. Evidence is limited, but one inference is that a mix of slow rise and brief spikes would be the most natural, since small worlds are rarely simple. Dust carries its own set of clues. As Mars watches from a shifting angle, forward scattering can brighten particles that would look modest from Earth. If large grains dominate, the brightness pattern across the coma will differ from a case dominated by fine grains. Omega can read those patterns and plot them against phase angle. Changes that track geometry argue for dust physics. Changes that ignore geometry argue for jets that are turning on and off. In either case, a well-sampled week will arm December observers with priors. They will know which behaviors to expect and which to challenge when Earth-based telescopes open again. There are limits. Data volume downlinks from Mars are not instant. Raw frames do not become calibrated products with a keystroke. Teams will correct for instrument response, for thermal drift, and for pointing jitter. They will cross-check lines against solar contamination and against Mars airglow when the line of sight grazes the thin atmosphere. That work takes days and sometimes weeks. Silence after collection is not a signal of suppression. It is a sign that careful people refuse to promise what they have not yet verified. The Mars window also helps with dynamics. Even if centroid measurements are coarse compared with large ground observatories, a string of positions over several nights pins the track across a small arc. Those points fold back into the global orbit solution. Later, when Earth rejoins, the combined pre-perihelion and post-perihelion astrometry will reveal whether the object received a measurable kick from gas jets. If the residuals align with the thrust directions implied by the spectra, the natural picture stands taller. If they do not, the puzzle sharpens and earns more attention. Risk again stays off stage. The separation at Mars is a comfort. The campaigns are designed to gather information, not to guard against impact. That clarity lets the narration relax into wonder. A planet that we have studied for decades lends its orbiters to a quick look at a traveler from another Sunday. The scene feels like a relay in a long race. Earth hands the baton to Mars for a few laps, then Earth takes it back in December and runs with fresh lungs. From this outpost, the story turns toward vision loss at Earth. The glare grows. Mars finishes its week. The sun takes the stage. Coronagraphs offer only sketches. Patience becomes the scarce resource. The next part will live inside that scarcity. We will ask how to think during a blackout, how to keep predictions honest, and how to prepare for the moment when the light dims and the numbers return. Begin with a photograph that seems to defy instinct. A soft head of light, a sweeping veil, and a thin spike that appears to point toward the sun instead of away. The first reaction is close to disbelief. Radiation pressure should push dust outward. The solar wind should comb material into a flag that streams into darkness. Yet some frames show the opposite. The mind rushes to explanations that feel cinematic. Maybe there is thrust. Maybe there is control. The real answer is quieter. Perspective can lie to you if you do not ask which plane the dust occupies and from which angle you are peering across that plane. Imagine the comet leaving behind a sheet of dust that traces its path like pollen on a river. Not all grains behave the same. Very small grains feel radiation pressure strongly and peel away into the classic curved tail that arcs from the head. Larger grains feel pressure less. They lag along the orbital track and settle into a thin midplane ribbon. When an observer happens to look almost edge-on at that ribbon, the line of dust projects into a narrow spike that seems to point sunward. It is not a jet fighting into the star. It is a perspective effect called an anti-tail, a trick born from geometry and grain, size, rather than from exotic engines. The sky often plays these games. If you could walk around the comet in 3 dimensions and look again, the false spike would shift or vanish. The same cloud of particles would project into a different pattern. That is why dates and angles matter so much when images begin to circulate online. A frame taken at one phase angle may show a structure that seems to violate common sense. The very next night, as the geometry changes, the structure calms into the familiar sweep that you expect. Without the calendar line and the angle line, a still can mislead even a trained eye. There is a responsible thrill in turning a visual riddle into a lesson. Forward scattering can turn the near-sunward side of a dust sheet into a bright edge. Then the camera sees an apparent spike that is only an illuminated seam. Backscattering can dim the same seam a few nights later and restore the textbook shape. The coma is a fog that records the history of the last few days of activity, not a snapshot of a single breath. As the nucleus rotates and vents, as new grains join the flow, the sheet evolves. Perspective slices through that evolving sheet at a new angle each night and writes fresh illusions. None of this rules out jets that have real direction. Comets do fire narrow plumes when a vent opens on a sunlit scarp. Those plumes can point in surprising ways if the terrain funnels gas along a wall or through a throat. They can even appear briefly on the sunward side if local topography and rotation place a vent into a bright line of sight. The difference is that a real jet will carry gas signatures. A perspective spike will carry dust signatures. Spectra can separate these cases with patience. Dust gives you a smooth continuum rise and gentle color slopes. Gas gives you lines that switch on in specific bands. If a feature glows but shows no lines and changes with viewing angle, you are likely looking at an anti-tail. If a feature glows and carries lines and repeats with rotation, you are likely looking at a jet. The internet has its own physics that favors the striking frame. A single image with a wrong-way spike will travel farther than a careful explainer that walks through phase diagrams. That is understandable. Surprise is sticky. Yet surprise can live alongside method. When a frame amazes you, ask for context. Ask for the elongation, the phase angle, the filter, and the exposure. Ask whether the field contains background galaxies or star trails that could imprint artifacts. Ask whether the image was a stack and how motion was compensated. These questions do not drain awe. They preserve it by protecting the viewer from mirages. One possibility is that December brings a repeat of the sunward spike once Earth regains the object at a favorable angle. A competing view suggests that the change in geometry will sweep the anti-tail out of view and leave only the classic fan. It remains uncertain which set of angles we will have on the first clear nights. Evidence is limited, but one inference is that, if multiple observatories spread across longitudes to record the same feature with the same morphology and with matching dust-dominated spectra, the case for a geometric cause will become strong. There is a deep comfort in seeing how the weird becomes ordinary once you rotate the scene in your head. The comet does not cheat. Our brains do, because we love patterns and we love intent. The anti-tail teaches a gentler habit. Look up the angles, picture the sheet. Give geometry a chance to explain itself before you invite engines into the story. The reward is a richer sense of how light plays on dust, and how the moving stage of the solar system can make a simple plume look like a message. Begin with a small ritual that anyone can learn. Open an ephemeris service and type the object's name. A table appears with columns that look like code. Let them become pictures in your mind. R is distance from the sun, in astronomical units. Delta is distance from you. SOT, or phase angle, is the sun observer target angle, a measure of how much of the dust is being lit toward you. Elongation is separation from the sun on the sky, a warning bell for glare. These are not decorations for experts. They are guardrails for common sense. They tell you what could be true on a given night, and what is unlikely no matter how striking a frame looks. Brightness is the next ritual. Imagine that light fades with the square of distance, because it does. Double the distance, and the same object sends you 1/4 of the light. Now add a layer. Comets are not bulbs. They pump gas and dust as they warm. Activity increases as R shrinks. A curve that tracks brightness must juggle both geometry and physics. This is why the most honest graphs show dates on the bottom, and both R and delta as companion lines. When a viral image claims a sudden surge, check the table first. Did elongation change? Did the phase angle swing into a forward scattering zone? Did delta drop sharply? If so, some of the surge is geometry. If not, the surge could be an outburst, or it could be a processing artifact that faded under the first hard question. Star fields can trick anyone. A faint galaxy in the background can add a smear that a quick stack will mistake for a plume. A field star that drifts through the aperture between frames can lift the measured brightness enough to invent a breath that never happened. The defense is not fancy. Plates solve the image so coordinates map cleanly. Check a catalog to see what else lives in the frame. Look at single exposures as well as stacks. If a feature depends on stacking, ask how motion was compensated. If the answer is only enthusiasm, put the claim on a shelf until others reproduce it. Colors matter in a different way. A continuum rising toward longer wavelengths suggests dust, since grains reflect sunlight with gentle slopes that depend on size and composition. Sharp lines at specific wavelengths suggest gas, since molecules sing at their own notes. Even a low-resolution spectrum can sort claims into likely dust features and likely gas features. A simple prism on a small telescope can be enough to keep a community honest. If you cannot split light yourself, look for observers who do and who post both the picture and the spectrum. A frame without context is a mood. A frame with a spectrum is a measurement. Timing is the thread that ties all of this together. Build a small notebook with dates and predictions before the glare arrives. Write down what each hypothesis expects. Layered nucleus means water should rise after perihelion, not before. Carbon dioxide heavy nucleus means water should remain the understudy. Stable jets mean non-gravitational residuals after December, should point as the gas points. Chaotic jets mean residuals will wobble or average out. Then wait. When new data arrives, compare lines to lines, not feelings to feelings. The sky rewards this discipline. It turns rumor into a choice between curves, and curves can be wrong or right in a way that everyone can see. Public tools make this work easier. JPL Horizons can output positions and velocities for any observer location. Many planetarium apps can render phase geometry for a chosen hour. Even the simple rule about elongation can prevent confusion. If elongation is under 20 degrees, most ground-based images will be poor or impossible. If someone posts a perfect portrait from such an angle, healthy skepticism is not cynicism. It is love for truth, dressed as patience. One possibility is that the first week after reacquisition brings a riot of claims about new tails and new motions. A competing view suggests a gentle return to a predictable light curve. It remains uncertain how noisy the online moment will be. Evidence is limited, but one inference is clear. The more people keep ledgers and check angles, the faster noise will fade in favor of shared plots. Each time someone asks for phase angle and filter instead of drama, the story tilts back towards science without losing any of its wonder. Reorientation of the through line. We are still pairing receipts with questions, teaching our eyes to separate geometry from physics so that awe survives contact with facts. Begin with a spinning coal in sunlight. Picture small patches that warm faster than their neighbors, pits and cracks that turn toward the star, pockets that vent gas as soon as frost loosens. Every molecule that flies away carries momentum. By conservation, the nucleus receives the opposite nudge. There is no sound, no plume you could ride. There is only a very small push that repeats thousands of times, and over weeks those whispers add up to a measurable change in the path. Astronomers look for these changes through a careful ritual. They fit the positions to a purely gravitational orbit first. The sun and planets provide the pulls. If the fit is perfect, residuals scatter randomly around zero. If jets are at work, the points drift in a favored direction by tiny amounts. You can model that drift with simple terms that stand in for thrust along three axes: radial, transverse, and normal to the orbital plane. The math is humble, but the meaning is profound. It tests whether the body is a comet doing comet things, or whether the motion asks for more than sunlight, gravity, and venting. The jets themselves are set by terrain and rotation. Imagine a rim that faces sunrise each spin and wakes like a geyser. Each time that rim turns into light, a short thrust vector points in almost the same direction in space. A single spin does nearly nothing. 100 spins write a faint but coherent fingerprint in the orbit. The period matters. A rotation that is stable will reinforce the pattern. A rotation that drifts will smear it. In December, when Earth regains a clean view, light curves can hunt for repeating brightness modulations that betray the spin. Pair that period with a model of active areas, and the predicted thrust directions become part of the orbit fit. Gas production rates ground the entire exercise. Spectra tell us how many molecules are leaving per second. Thermal models estimate their average speed. Multiply those and you have a momentum flow. Divide by a guess for the nucleus mass, and you have a predicted acceleration. One possibility is that the measured residuals after perihelion will match this calculation to within reasonable error. That would be a direct handshake between chemistry and motion. A competing view suggests that the residuals could be larger or misaligned, which would hint at hidden assumptions in the models, such as wrong mass, unseen vents on the far side, or dust forces that were ignored. It remains uncertain which way the numbers will lean. Evidence is limited, but one inference is that a joint fit using both astrometry and spectra will push the solution toward honesty. There is a temptation to leap to exotic thrusters when residuals refuse to behave. History cautions against it. A poor model for how thrust changes with distance can look like a mysterious force. An unrecognized change in rotation state can scramble the vector math. A light nucleus can masquerade as strong thrust if everyone assumed a heavy one. The cure is not clever rhetoric. The cure is more positions, more nights, more patience, and better priors from the chemistry. The Mars window helps, even if its positions are coarse. A handful of detections over a week near closest approach to Mars adds control points to the trajectory just before the glare. When Earth-based observatories resume in December, the combined arc spans both sides of perihelion. That is exactly when jets are likely to change behavior. The heat wave will have penetrated deeper. New vents may open, old vents may choke with dust. If the thrust term that best fits the pre-perihelion side fails on the post-perihelion side, the change itself becomes a clue about the layering of volatiles. Dust complicates the bookkeeping in subtle ways. Large grains leaving at low speed can carry momentum too. If a burst sends a spray of big grains, the gas lines may not fully account for the push. Photometry that tracks the continuum can flag such episodes. In that case, the non-gravitational term belongs to gas plus dust, and the mass inference must widen its error bars. This does not break the method. It just insists that dynamics, spectra, and photometry travel together. What would count as a genuine surprise? A residual pattern that points in a direction inconsistent with any plausible vent geometry. An acceleration magnitude that exceeds the budget implied by all observed volatiles by a large factor. A repeatable change in brightness that suggests a shutter or a plane rather than a vent. None of these are expected. All of them are testable. The most likely outcome remains a comet with gentle thrusters that match its breath. The next part looks back to a slender precedent that taught the field how easy it is to overfit thin data. We will borrow its lessons, then return to our present traveller with a clearer standard for when a puzzle is truly puzzling and worth a stronger claim. Begin with a shard that crossed our sky like a rumour. Years ago, an earlier interstellar object arrived with a light curve that flickered and a motion that did not align perfectly with gravity. The community named it and argued over it, and then watched it leave before the case could be closed. That visitor taught a specific lesson that matters now. Data windows can be short and seductive. When the arc is thin, models that seem elegant can be built on sand. The light curve of that earlier object pulsed in a way that suggested a highly elongated shape, or a tumbling plate. Some artists drew a cigar. Others painted a flat chip. Photometry alone could not decide. The brightness changed because the cross-section toward us changed as it rotated. Without a resolved image, 1,000 shapes can mimic the same up and down rhythm. The absence of detected gas added intrigue. If vents were active, the gas lines were too faint to record with the instruments that happened to be online. Yet the trajectory still showed a small but real deviation from a purely gravitational path. That mismatch lit a fire that never quite went out. One possibility that rose quickly was that sunlight itself was pushing on a very low-density object. A competing view suggested that outgassing was present but stealthy, perhaps dominated by volatiles that were not easily caught by the available spectrographs. It remains uncertain whether either explanation captures the whole truth. The debate became a parable about evidence and about what happens when a mystery leaves the frame before your tools can sharpen. Without a longer baseline, the space for interpretation is large. The earlier object gave us just enough to disagree and not enough to agree. From that case, several habits worth keeping emerged. Treat residuals with suspicion when the data span is short. Check whether a small change in an assumed parameter can swallow an apparent anomaly. Ask whether unseen dust could have carried more momentum than the gas line suggested. Resist the impulse to treat a null detection as proof of absence. An instrument that is not sensitive to a given molecule at a given temperature cannot read its song even if the song is there. Most of all, separate what the numbers force you to say from what your story-loving mind would like to say. There is also a social lesson. Public fascination grows faster than calibration. The earlier visitor became a cultural character overnight. Headlines announced an enigma, then rushed to hypothesize machines and sales. Responsible voices tried to match pace with measured words, and often lost the race. That imbalance is not a failure of science. It is a feature of the media environment. The cure is not to withdraw. The cure is to offer clear tests as soon as possible, and to label them with the humility they deserve. When you cannot measure again, you say so. When you can, you promise to return with better tools. Our present traveller arrives with an advantage. The window is longer, spectra already exist, and show chemistry that is odd but concrete. Mars offers a set of looks during a week when Earth turns away. The path after perihelion brings a second act that ground observatories can capture with patience. We will be able to test whether non-gravitational acceleration aligns with observed gas production and with dust behavior. We will be able to search for periodicities in the light curve that match a rotation period, then check if thrust vectors inferred from vent geometry line up with the residuals. We will be able to watch for a shift from carbon dioxide dominance toward water, or for the stubborn persistence of the current order. The lesson of the slender mystery is portable. Do not let enchantment replace arithmetic. Do not let a short span bear more weight than it can carry. Do not let a null detection become a creed. When a claim rises to the level of extraordinary, ask for extraordinary data, or for a path that could produce it. If that path does not exist, say the words that rarely trend but always age well. We do not know yet. We will look again soon. With that standard in hand, the next section returns to the chemistry that started our current wonder. A spectrum that flipped expectations once can flip them again, or it can double down. Either way, the way lines change will put to work every lesson that a brief and controversial visitor left behind. Begin by putting the spectrum back on the table like a crime scene photo. A quiet sequence of bands tells you who is in the room. One set glows with the confidence of a lead actor. Carbon dioxide sings bright and loud. Water, the usual star in local comets, clears its throat from the side. A reported ratio near 8-1 in late. Summer rewrites the casting sheet. This is not what most students of our backyard expect. It is not an accusation of anything unnatural. It is a clue that the pantry of this traveller was stocked under rules that differ from those that shaped our usual long-period visitors. Imagine 2 kitchens separated by light years. In one, like ours, the water shelf is full and the carbon shelves sit below it in the recipe order. In the other, colder or more carbon-rich, carbon dioxide is the ingredient that piles up near the surface. That difference would be enough to flip the order of lines in a coma once the object warms. The sun lifts the lid. The first smell that escapes is carbon dioxide. Water lingers deeper and needs more heat and more time. If you accept this kitchen picture, a clean prediction follows. After perihelion, once the thermal wave has travelled inward, the water bars should climb on the plot. They do not have to dominate. They do have to grow. If they do not, the case for a fundamentally carbon-heavy body becomes stronger. There is a second picture that can live beside the first. Layering and crust can complicate any recipe. Many comets show surfaces that evolve into dusty lids that slow the escape of volatiles. Gas pressure builds under these lids, cracks open, jets fire, then the surface sags and seals again. In such a body, the early spectrum can be a partial truth. Carbon dioxide at the skin escapes through slight pores with ease. Water that sits only a little deeper waits for a crack. When a crack arrives, even briefly, water lines spike, and then they fade when the lid reforms. In this picture, the ratio will oscillate with rotation and with the cadence of crust failure. The way to test this is simple in principle and slow in practice. Collect time series spectra over weeks, look for repeatable short spikes, and for a slow background climb. A third possibility is the plainest. The interior is poor in water to begin with. The lines will not rearrange themselves after perihelion because there is nothing there to lift. Carbon dioxide will continue to dominate as the object moves outward. The overall brightness will fall as distance grows, yet the relative strength of bands will keep their early order. That is a duller prediction to some ears. It is also a thrilling one to planetary chemists because it implies a birth zone with a carbon-to-oxygen rhythm that differs from our molds. It points to diversity among planet-forming disks and to a larger gallery of comet recipes than the one that local experience prepared us to expect. While chemistry sets the cast, dust sets the mood lighting. Large grains can tilt the continuum and can hide the subtle rise of waterlines if analysis is not careful. That is why any claim about changing ratios must travel with a clean account of continuum subtraction. Dust also listens to the jets. If a vent that carries more water also lifts larger grains, the dust slope will change in step with the water lines. Pairing those evolutions on the same timeline will protect us from being fooled by a brightening that is only a glitter shift and not a true molecular change. Rotation can act as the metronome. If the nucleus spins with a stable period, surface composition that is patchy will present a sequence of faces to the sunday that will set a clock in the gas production rates. A line that rises every time a particular longitude comes into morning is a fingerprint of terrain. If a period drifts in December relative to August, torque from jets may be rewriting the spin. That drift can explain changes in average ratios, even if the pantry is the same. In that case, the chemistry would appear to evolve when the real change is the schedule of vents. There is comfort in how testable all of this is. Mars offers a first chance to watch for short spikes. December offers a baseline shift test that is sharper than any argument. If water grows, the layered story stands taller. If water stays quiet, the carbon-heavy birth story steps forward. Evidence is limited until the next spectra arrive, but patience can turn limited into enough. A minority view holds that an extreme ratio already implies a non-natural process. That claim carries no weight until residuals, radio searches, and light curve analysis all fail in ways that point in the same direction. The more likely outcome is a natural comet that chose a different kitchen, and the fun of science is that such difference is a prize, not a letdown. As the cameras prepare to rest for a glare-filled month, hold the plot in your mind. Bars on a graph can change like weather. Some changes are slow fronts, some are lightning. When Earth looks again, the lines that grow or do not grow will fold into dynamics and will narrow the space for stories that only feel right. Chemistry will be the voice that tells us whether the interior matched the skin or contradicted it, and that answer will drive the next chapter on how and why the light sometimes flickers like breath. Begin with a crust you can almost hear. Sunlight crawls across a surface that is not smooth. Dust and ice have settled into a thin lid that hardens when gas escapes and leaves behind grains that do not evaporate. Beneath that lid, volatiles warm and turn to vapor. Pressure gathers in pockets like whispers under a door. Then a seam gives way. Gas rushes out, lifting dust in a brief fountain. The coma brightens, then settles. Hours pass. The skin cools and sags. The seam stiffens again. From a distance, the comet appears to breathe. Outbursts are the punctuation marks of small icy worlds. They happen on many comets in our neighborhood. Some are tiny blips that raise brightness by a fraction of a magnitude. Some are rare flourishes that transform a faint speck into an easy target for binoculars. The causes can differ, yet the stage is similar. Layered ices, dust blankets that throttle flow, fractures that connect shallow voids to space. When the thermal wave advances, stress builds where materials with different strengths meet. A crack can form along an old fault. The result is a short jet, a spray of rocky flour, and a new pattern in the light curve that looks like a heartbeat. The rhythm of these pulses is not random if the nucleus rotates with a stable period. Imagine a field of hot spots spread across longitudes. As the comet turns, the sun wakes each in turn. Some vents are young and wide. Some are choked by grains that settled after previous events. Around sunrise on that longitude, pressure peaks. Around local noon, the vent has spent itself, and the jet fades. If you plot total brightness every 10 minutes, you may see small ripples on the larger trend. If you plot spectral lines for carbon dioxide or for water, you may find short surges that match the same phase. That match is the signature of rotation, acting as the metronome of activity. A layered nucleus offers a second path to pulses. Carbon dioxide, which needs less heat to sublimate, becomes active first in the upper centimeters. Water waits below. The thin lid above these layers can act like a cork. Gas gathers. The lid bows and cracks. A spike in water lines appears for a few hours, then falls as the vent reseals with a dust fall. Evidence is limited, but one inference is that if Mars instruments catch a rising waterline that coincides with a fall in the continuum slope, large grains may have lifted during the crack event. In that case, the dust carries part of the momentum budget for later orbit fits, and we must count it. There is also the possibility of a thermal avalanche. Sunlight steepens a wall inside a pit. Grains that had clung for months let go. A cascade exposes fresh ice and opens a path for gas. The brightness jumps, not because the whole comet changed state, but because a small patch found a new way to vent. These events can reset the rotation state by a tiny amount. Jets act like torques. The spin speeds up or slows down, imperceptibly at first. Over weeks, the period shifts by seconds or minutes. The next time you phase fold the light curve, you will find that your old clock is off. The shift is not a nuisance. It is evidence that the nucleus is alive in the mechanical sense. How do we separate breath from artifact? First, demand time series from multiple sites. An outburst that is real will leave a trace across longitudes. Second, ask for spectra that ride along with the images. Dust-dominated spikes will show continuum changes. Gas-dominated spikes will light specific lines. Third, compare with geometry. If a surge aligns with a sudden drop in phase angle, or with a swing into forward scattering, the surge could be more about angle than about physics. If the surge ignores geometry and repeats at a consistent rotation phase, it is likely a vent-driven pulse. One possibility is that early October yields a quiet week at Mars, small ripples and no fireworks. A competing view suggests that at least one short spike will break the surface calm and reveal the crust at work. It remains uncertain how frequently such events might recur. A fragile lid could produce many small sighs. A stronger lid could hold until perihelion, then fail once in a larger gasp. Either pattern would teach us about the structure, about the grain sizes on the skin, and about how quickly the comet can rebuild a cap after rupture. The breathing metaphor is not only poetic, it points directly to tests that December can perform. If a period emerges from the ripples, then thrust directions associated with that period can be applied to orbit fits. If water lines pulse during specific phases, then the layered picture gains credibility. If pulses never rise above noise and the coma glides with grace, then we may be looking at a body with either a gentle skin or a pantry that lacks deep water. Each answer constrains the chemistry we will compare to a previous interstellar visitor in the next act. Begin with a split screen, and in your mind. On one side, the present traveller, bright with carbon dioxide and full of questions. On the other side, a visitor from a few years ago, 2I Borisov, a comet that behaved in a way the textbooks could carry without too much revision. The comparison does not exist to crown a winner. It exists to clear a path through our expectations. When two interstellar guests act differently, the difference itself becomes evidence that there is no single mold for worlds born under other suns. Borisov arrived with a chemistry that, while unusual in places, felt familiar in structure. Water was present. Carbon monoxide was prominent, strong enough to raise eyebrows, but the overall pattern sat inside the family of known comet compositions. Its activity grew in a way that made sense as it approached the Sunday. Photometry told a steady story. Spectra did not stage a coup. If you plotted its lines on a board beside fresh observations of long-period comets from our own cloud, you could point to clear differences, but you could also draw a box and say that Borisov lived inside it. Now, place 3I Atlas on the other panel. The reported ratio of carbon dioxide to water, near 8:1, reads like a refusal to enter the box. Water is not absent. It is quiet. Carbonyl sulfide peeks in as a trace, which adds texture to the tale of a different pantry. The light shows flickers that could be ordinary pulses, but their timing and shape remain to be nailed down by Mars and by December. If you were to sketch the two spectra side by side, one would speak in a dialect that we know, the other would speak with a throatier carbon voice that makes you lean forward. Both are natural. Both are interstellar. Each pushes on the boundary of what we expect in a different direction. Dynamics offer a second axis for comparison. Borisov did not demand exotic forces to fit its path. If non-gravitational terms were used, they aligned cleanly with venting. The object behaved like a comet that had wandered in from a distant cloud that was not ours. For 3I Atlas, the test has been outlined earlier. Measure positions across months. Fit gravity first. Add jet terms that are grounded in observed production rates. See whether the residuals relax. The prediction favored by experience is that they will. If they do, the parallel with Borisov grows stronger. If they do not, the difference becomes a prompt to examine assumptions about mass, about dust, or about rotation state. There is a caution the comparison can teach. Anomalies often feel larger when they are new. Borisov felt tame in part because it arrived in the shadow of a more controversial predecessor, and because its chemistry did not stage a dramatic inversion. 3. Atlas feels wild because it flips a ratio that anchors many comet lectures. Over time, as more interstellar objects enter our telescopes, the space of what feels normal will widen. The present shock may recede into a range of possibilities we now lack the sample size to imagine. Diversity is the rule in planet formation. Interstellar traffic will likely prove the rule again. Still, difference is not an excuse to let our standards drift. The comparison must be fair. Distances at observation must be taken into account. Instruments and sensitivities must be considered. A line measured with one spectrograph at one time cannot be pushed against a line measured by a different machine at a different geometry without adjustment. The honest way to compare is to reduce spectra under the same assumptions and to observe at similar solar distances if possible. That is why the coming December window is so crucial. It lets us stack our present pages beside Borisov in a way that respects what measurements can and cannot say. There is a final lesson in tone. Borisov's steady behavior did not dim the wonder of an interstellar guest. It sharpened it by showing that other kitchens can produce comets that our physics already knows how to read. 3. Atlas does not need drama. Beyond its data to feel important, carbon dioxide that refuses to give way, a path that offers a Mars whisper during an Earth blackout, a set of tests that can draw clean lines between layered crust and deep composition. These are enough to carry a film. The comparison to Borisov helps by reminding us that natural variety already fills the sky. When we call something weird, we can mean it with a smile, a scientific smile that expects the universe to be more inventive than our first few examples suggest. So we carry both portraits forward, the calm and the carbon-rich, the textbook and the twist. The next scene will turn from interstellar cousins to human cousins, how a quiet meeting on a military base stepped into the same frame as a bright visitor, and why coincidence can paint meanings that measurements do not support. Begin with two calendars that share a page. On one, a red circle, around early October, when a visitor from another star brushes past Mars. On the other, a line of headlines about a large short-notice gathering of defense leaders at a U.S. base, known for training and briefings. The words are ordinary, strategic discussions, ongoing operations. The timing is not ordinary. Our minds pull the two pages together as if they were halves of a ripped photograph that now seem to match. The effect is powerful because it is human. We look for stories that connect. The safer story sits in daylight. Institutions meet, space objects pass. Sometimes, these events happen in the same week. Sometimes, big rooms fill at bases while small comets pass in silence. Most of the time, there is no bridge between them. There is none that we can point to here. No public memo ties an agenda to a comet. No on the record quote asserts a connection. The headlines mention urgency and size. They do not mention the sky. That absence is not proof of anything. It is an absence. Yet optics matter in a narrative, and the optics here deserve study, not for what they prove, but for how. They bend perception. A quiet science month becomes louder when placed next to a quiet security week. The silence of one colours the silence of the other, and the result looks like a shadow larger than either object can cast alone. In such light, people fill in the blanks with what feels plausible. A traveller passing near Mars, a gathering of leaders who share jurisdiction over satellites and sensors. The inference writes itself. Of course they are related. The calendar must mean contact. One possibility is that the meeting simply reflected the churn of world affairs on Earth. Budgets close, commands turn over, regions heat up. A competing view suggests that any unusual object in the sky, even if no threat, could trigger a desire for synchronized situational awareness, and that a calendar collision is not surprising. It remains uncertain whether either view explains anything real about this specific week. Evidence is limited, but one inference is that coincidence plus a vacuum of detail tends to create narratives faster than facts can prune them. There is also a media dynamic at work that favors alignment over disjunction. Headlines cluster to help audiences find interest. Two stories in the same news cycle are often framed as a single mood. A single mood is easier to sell and easier to remember. Science communication then inherits the mood whether it wants it or not. The solution is not to scold an audience for pattern seeking. The solution is to name the pattern and separate it from the claim. We can say out loud that the overlap is eerie. We can say with equal clarity that eerie timing does not equal causation. Imagine the opposite case as an exercise. If the meeting had occurred a month earlier, would anyone pair it with the comet? If it had occurred a month later, would anyone claim a debrief? The answer is probably no. The association only blooms where proximity lives. That is a clue that we are reacting to a cognitive shortcut, not to a hidden cable of cause and effect. Once you see the shortcut, you can keep the thrill and let go of the pull towards certainty. The calendar can keep both marks without forcing them into one story. Transparency would help, but transparency has rhythms and limits. Security institutions communicate after internal cycles close. Science institutions communicate after calibrations complete and partners align. Neither can or should run on rumor time. When they both seem slow, the vacuum deepens. This film tries to fill the gap with tests rather than with claims. If anything truly unusual were happening with the object, radio telescopes would light up in a hurry. Observatories in many countries would aim without being asked. Amateur networks would post raw spectra by the hour. The absence of that chorus is a useful negative. It suggests that what we have is a fascinating comet and a separate human meeting that shared a page on the calendar, nothing more. A minority view holds that silence itself is a signal. That view asks us to believe in perfect control over a global community that has never been quiet when there is real sky to chase. It asks us to believe that hundreds of independent observers would refrain from posting because someone somewhere asked them to wait. That picture strains at the seams. The louder and more distributed the tools of observation become, the harder it is to keep a secret about the sky for long. So we let the optics be optics, and we return to the places where evidence lives. Mars data will either show chemistry evolving or not. December positions will either match predicted pushes or not. The meeting at the base will fade into the archive of meetings. The comet will move on. Our task is to keep curiosity honest, while the plot tempts us with convenient alignments. The next part will show how to store that curiosity safely, in labeled jars of possibility with predictions written on the glass. Begin by clearing a counter and setting out empty jars. Each jar, they will hold one story we could tell about this object. Each label carries a prediction that can be checked. Curiosity is allowed in the room, but it must put on a lab coat. The rule is simple. If an idea cannot make a bet against the calendar or against a measurement, it does not get a jar. The purpose is not to mute wonder, it is to keep wonder from running the budget. The first jar is the natural carbon dioxide-driven comet. The label reads that the birth kitchen favoured carbon over water near the surface. Prediction 1 says carbon dioxide should remain strong before and after perihelion. Prediction 2 says water may rise a little as depth warms, but it will not take the lead. If December spectra keep the ratio high, this jar fills with confidence. If water climbs sharply and stays loud, the lid goes back on and the label is revised. The second jar is the layered nucleus, with a thermal bottleneck. Here, carbon dioxide sits on top, water waits below, and a dust lid restricts flow. The label promises a slow increase in water lines after perihelion, possibly decorated with brief spikes when cracks open. The dynamics tag adds that thrust directions can change as deep events wake. If Mars sees short pulses in October, and Earth sees a clear rise in water in December, this jar earns a place on the front row. The third jar is episodic crust failure with pocket outbursts. The picture is of cavities that hold pressurized volatiles until a seam fails. The label promises irregular brightening, short-lived line surges, and possible changes in dust slope if large grains are lofted. The test demands time series from multiple sites and spectra that catch the spikes. If only geometry explains the flickers, this jar stays light. The fourth jar is apparent control from repeatable jets. This is the idea that natural vents, locked to rotation and terrain, can create thrust that looks coherent. The label sketches a rotation period, a map of active longitudes, and thrust vectors that repeat with each spin. The test is a match between light curve phase, jet direction from coma morphology, and the sign of the non-gravitational residuals. If the match holds, we do not need intent to explain order. The fifth jar is the carbon-rich through-and-through body. No layers, no late water. The label is blunt. Ratios do not change much across the season. Dust behavior follows geometry rather than vents. Dynamics stay within the budget set by gas production with minimal need for dust momentum. If December brings little evolution and January brings even less, this jar becomes a quiet favorite. The sixth jar is hybrid artifact. It keeps a space on the shelf for the extraordinary without granting it the main table. The label demands a smoking gun, radio emissions with structure, acceleration directions that defy any plausible vent geometry, spectral lines that cannot be matched to known molecules at relevant temperatures. The test here is harsh on purpose. If an idea is this large, it must carry itself with evidence that does not blink in the light. The seventh jar is new physics. The label warns that this jar is usually empty. Any claim that gravity or radiation pressure behaves differently must survive a swarm of simpler explanations. Only if residuals remain after every known force is counted, only if multiple instruments agree, only if the anomaly repeats across seasons, does this jar get a pebble. Now we write on the glass the kind of tests a viewer can understand. Dates for Mars, dates for perihelion, dates for Earth to return, instruments that look for lines, telescopes that record positions. Each jar earns or loses weight when those moments arrive. The point is not that any single jar must win. The point is that the bank as a whole keeps the story honest. We do not need to shout down ideas. We let time and light sort them. One possibility is that two jars fill at once. Layering may be true, while episodic outbursts also occur. A competing view suggests that a single, simple story will explain nearly everything. A carbon-heavy nucleus that behaves without drama. It remains uncertain which style of answer we will prefer in the end. Evidence is limited, but one inference is already clear. The process of writing predictions before the data forces humility. It also makes December feel like a promised chapter rather than a cliff. The final act of this scene is to put the bank on a shelf where we can reach it quickly. When Mars releases first looks, we add a note to the labels. When coronagraphs hint at survival or at stress, we add another note. When Earth regains sight, we stop adding notes and start crossing out or underlining. The jars do not care about our mood. They care about whether reality picked their label. That is the beauty of such a bank. It turns speculation into a ledger that anyone can audit. Begin by imagining a control room that runs on patience. Screens show thin lines stepping across time. No fireworks, no portrait of a nucleus, only spectra that rise and fall with a discipline that would bore anyone who chases drama for a living. Here, success is quiet. Nomad on the Trace Gas Orbiter pulls in light and turns it into bands that can be counted. ACS repeats the pull at a slightly different set of wavelengths. Mars Express builds maps of how dust brightens when the sun sits behind it or beside it. In this week of good geometry, the instruments can walk a straight line through the noise and leave us with curves that carry meaning. Define the wins before the data arrives so that the story does not move the goalposts. The first win is consistency. Carbon dioxide lines that appear at the expected places with the same calibration from pass to pass. Small variations are fine. Large jumps that track instrument temperature would warn of trouble. The second win is evolution that makes physical sense. If a layered nucleus is real, water lines might be faint on the first night and a little stronger on the last. Not a leap, a lean. If a cracking crust is active, 1 or 2 short spikes might decorate the trend. The third win is geometry behaving like geometry. Dust scattering that brightens as phase angle favors forward scattering. Morphology that shifts as angles change, not as rumor winds blow. There are also winds that feel like detective work. A faint waterline that rises across several orbits of Mars would be a small flag for the layered picture. A trace species that winks in, carbonyl sulfide for instance, would hint at a pocket emptying or at a patch with odd chemistry. A change in the continuum slope that matches a short spike in water would suggest that larger grains rose with the outburst. Each of these saw cuts across a thick plank of uncertainty and makes December less of a guess. Calibration is the drumbeat under every result. The teams will subtract backgrounds, correct for instrument response, and check for stray light from Mars airglow when the line of sight grazes the atmosphere. They will compare repeated observations of the same star to confirm that nothing has drifted in the optics. They will trim exposure times to fit within the dynamic range of the detectors so that a brightening does not saturate a line and turn truth into a flat top. If a line is near a region where the instrument is less sensitive, they will carry larger error bars and say so. That honesty is part of success. Numbers that look smaller or slower because of caution are better than numbers that leap because caution was ignored. Astrometry from Mars is a different kind of prize. Even a handful of positions over several nights improves the orbit just before the blackout. Those points become pegs that hold a tent. When Earth returns in December, the pegs keep the canvas from flapping into confusion. If non-gravitational accelerations have begun to grow near perihelion, the fit that uses only gravity may already show a hint of strain. Add a simple jet term, and the strain may relax. If it does, we carry that term forward as the model to beat after Earth rejoins. If it does not, we keep the strain in view and ask whether dust, momentum, or a wrong mass assumption is to blame. Communication from Mars teams will not be breathless. Expect a small post that says data taken, calibration in progress. Expect a figure with axes labeled and no superlatives. That is how you know the work has begun to matter. The first rich release will likely be a short stack of spectra with water and carbon dioxide bands marked, plus a paragraph that says whether the ratio remained steady or tilted in any direction. If there was a spike, it will be described with times and with caution. If there was none, that is not a disappointment. It is a constraint. A coma that holds steady through this week tells us that the stronger changes will belong to the perihelion zone, which is what our physical intuition said in the first place. One possibility is that Mars delivers a gentle trend upward in water and a few hours of small flutter in carbon species. A competing view suggests that the lines will look nearly identical from night to night, a flat chant in carbon dioxide with little else. It remains uncertain which outcome the instruments will be able to resolve within a week. Evidence is limited, but one inference is safe. Any evolution that stands above the error bars on these platforms will almost certainly grow clearer in December, when larger apertures and longer integrations return to the field. Mars is the bridge. Its job is not to carry us to the far shore in one span. Its job is to keep our feet dry while the river is swollen with glare. Success from Mars is the kind that hides from headlines, curves that make sense, error bars that grow when they must, small moves that become big once you step back. When the week ends, the baton passes to the sunlit stage, where Earth cannot stand. Coronagraphs take their sketches. The object moves through its hottest hour. The next part climbs into that crucible and lays out the futures that could emerge when our eyes can finally open again. Begin with heat as a character. The object draws to its nearest point from the sun near 1.4 astronomical units. That distance is not a dive into danger. It is still far outside the roiling crown where sun grazers meet their fates. Yet, for a nucleus that has slept in deep cold, this is summer. Ices that held for ages find their thresholds. Dust that rested across seasons begins to move. The skin warms fast. The interior warms slowly. Between those two speeds, stress collects like water behind a dam. 3 futures wait behind the glare. The first is graceful survival. In this story, the coma brightens as expected with rising insolation. The glow remains compact around a central condensation. The light curve climbs, crests near the thermal peak, then begins a steady decline as distance from the sun grows again. When Earth looks back in December, spectra show a chemistry that has evolved, perhaps with a modest lift in waterlines if layers are real, perhaps with carbon dioxide still leading, if the pantry is carbon-rich through and through. The orbit fit shows non-gravitational terms that match the push implied by the gas measured. The surprise is how unsurprising it all is. This outcome is not dull. It is the baseline that lets every nuance count. The second future is structural failure, not a cinematic explosion, a surrender by cracks. Imagine a fragile lid that bridges pits and hollows. As heat advances, the lid buckles along old faults. Segments of the nucleus separate by a few meters or by hundreds of meters. The coma swells into a more diffuse cloud. Brightness may spike briefly, then fall below the track predicted before perihelion. When Earth regains its view, the central point has softened into a smear, or into multiple points that drift apart. Astrometry becomes harder because there is no single coal to pin with a centroid. Spectra tilt toward dust continuum as grains dominate, and gas production becomes less efficient per unit mass. This outcome is less likely at this distance than for a true sun skimmer, yet it is not forbidden. The test is simple. A coherent head reappears or it does not. The third future is the flare. Somewhere in the crust, a seam opens into a deep pocket. Gas escapes in a rush. Large grains ride the flow. The coma swells beyond expectation. Solar observatories that can stare near the sun see a point brighten sharply for a day or two. Later, the object that Earth reacquires in December is larger and brighter than the pre-perihelion curve had forecast. Spectra show lines that were faint in August, now louder for a time. Dust slopes tilt if big grains were lifted. The orbit fit may show a slightly larger non-gravitational term because the momentum budget during the flare was larger than usual. This future excites attention for good reason. It is dramatic and still natural. The energy comes from sunlight and from chemistry. No special engines are required. Thermal physics explains why all 3 futures can live in one sky. Heat penetrates an ice and dust matrix by conduction. The depth reached in a given time is measured in centimeters and meters, not in kilometers. That sets a lag between the moment of maximum sunlight at the surface and the moment of maximum response in deeper layers. The coma can therefore peak after the date of perihelion, not exactly on it. Delays matter for chemistry. If water sits beneath a layer of carbon dioxide, its voice will rise after the sun has already begun to recede. Delays also matter for structure. If stress takes time to concentrate along a seam, a crack can propagate when the calendar insists that the crisis has passed. December sees the consequences as if they were a fresh act. They are the echo of an event that happened behind the glare. One possibility is that solar observatories will catch only hints, a point that keeps its shape. A. Brightness that follows a gentle arc. A competing view imagines a ragged trail that hints at fragmentation without granting a clear count of pieces. It remains uncertain what those cameras will see because their resolution is set by their mission to watch the sun, not to portray distant comets. Evidence is limited, but one inference is solid. The sketches from coronagraphs will set the tone for reacquisition. If the point appears steady, observers will prepare for endurance. If it appears ragged, they will prepare to chase a cloud. The crucible of perihelion is therefore both a heat test and a patience test. It puts the nucleus under stress that reveals structure and composition in ways no other moment can. It also hides much of the show from us. That is not a flaw in the story. It is the story. When the glare lifts, we will read the ashes and the survivors. We will use positions and spectra to tell which future arrived. The next part will climb onto the shoulders of the solar eyes and describe what those sketches can and cannot reveal while we wait for the bigger mirrors to return. Begin by picturing a camera with a black coin held up to the sunday. That coin blocks the blinding disk and lets the faint halo around it appear. This is a coronagraph. Its job is to reveal the solar wind, the slow flow of charged particles, and the bright ropes of a coronal mass ejection. When a comet strays into this ring of artificial twilight, the instrument becomes a sketch artist. You will not get chemistry. You will not get the crisp outline of a nucleus. You will get motion, brightness trends, and the coarse shape of any dust that the sun lights from the side. The strengths are humble, yet powerful. First, continuity. These platforms watch for hours and days without the interruptions that ground observatories suffer. If our visitor brightens abruptly near perihelion, the curve will be traced in near real time, a rise, a crest, a fade. Second, survival checks. A coherent point that sails through the field night after night argues for structural integrity. A smear that broadens or splits argues for stress or fracture. Third, context. Coronagraphs reveal the solar environment around the comet, so any flare in brightness that coincides with a solar outburst can be logged, not as cause and effect, but as a pair of events worth keeping near each other on the timeline. The limits are equally clear. Resolution is coarse because these instruments were built to image the sun and its near space, not distant small bodies. A nucleus that spans kilometers at hundreds of millions of kilometers distance will always be unresolved. Dust structures that look like fans or spikes may be real, or they may be the result of projection in a crowded field. Spectra are absent, which means there is no way to separate dust scattering from gas emission in a single look. Even the brightness scale can be tricky, since calibration is optimized for the corona, not for point-like moving targets. All of this means that coronagraph footage is a map drawn with broad strokes. Useful, but dangerous to overinterpret. So how do we use those broad strokes well? First, treat brightness changes as hints that need ground truth from Earth in December. A rise that would be sensational in a press release becomes a prediction to test with larger telescopes later. Second, look for symmetry. A tidy coma and a consistent tail direction over many hours suggest ordinary dust dynamics. A shape that stretches in multiple directions at once, or that shows a sudden fan with no solar wind change, hints at internal events such as a vent opening or a slab shedding. Third, watch the track against the star field. Astrometry from these images is rough, yet a precise timeline of positions can still be extracted if many frames are stacked and measured. This yields a sanity check on the orbit that will matter when adding non-gravitational terms in the weeks after perihelion. There is a special case that merits patience: fragmentation. If the nucleus breaks, you may see a head that elongates and then resolves into two or more bright spots, each with its own small coma. Coronagraphs have recorded such scenes for true sun divers. For a perihelion at 1.4 astronomical units, pieces would separate slowly on the sky and may never fully deblend at this resolution. The only honest move is to mark the possibility, then wait for higher resolution eyes to confirm. Overreading a fuzzy elongation, a certain breakup will only confuse the December campaigns that need clear planning. Noise has its own playbook here. Cosmic rays strike detectors and leave bright streaks that can be mistaken for debris. Compression can create blocky artifacts. Vignetting near the occulting disk can produce gradients that pretend to be diffuse dust. The cure is the same as always. Ask for multiple frames. Ask for independent processing from different teams. Trust features that persist from frame to frame and that move with the comet across the field. Distrust single-frame oddities that vanish when you blink to the next image. One possibility is that the coronagraphs show a steady point and a modest fan, a picture that whispers survival. A competing view imagines a brief bloom, a 2-day swell that then subsides, a picture that whispers outburst. It remains uncertain which whisper we will hear, but either one serves a purpose. A steady point will guide December observers to prepare for precision astrometry and long integrations on faint lines. A bloom will alert them to widen the search region and to expect stronger dust that could veil water signatures. Reorientation of the through line. These solar sketches cannot answer the chemistry, yet they will set the mood for reacquisition and will turn rumor into a short list of testable expectations. Begin with a winter dome sliding open, air spills in. Mirrors temper to the night. The object has moved away from the sun's glare, just enough that pointing limits relax. Screens refill with stars that stand still, and with one point that does not. Reacquisition feels like meeting a traveler at the far side of a tunnel. For weeks we had sketches. Now photons return with detail. The first order of business is humble. Confirm the position with precision. Fit the orbit with only gravity. Then check the residuals. If the points wobble in a single direction, add a simple jet term. See if the wobble calms. This is the handshake between dynamics and breath that we have been waiting to attempt. Spectroscopy follows on heels. Instruments that slept through glare wake with appetite. Teams who wrote predictions on paper in October now load those sheets beside the control keyboards. The recipe is straightforward. Target the water lines that were faint in August. Target the carbon dioxide region that carried the melody. Take exposures long enough to lift the lines above noise, but short enough to track changes within a night if the nucleus is pulsing. Then repeat on the next night and the next. The plot we are chasing is not just a single spectrum. It is a stack across nights that shows whether water has stepped forward or stayed in the wings. Photometry runs in parallel and plays referee. The continuum beneath the lines can tilt if dust grain sizes have changed. A tilt can mimic a chemistry change if subtraction is sloppy. So the teams will take care to match filters and to calibrate against standard stars. They will keep apertures consistent so that the same physical region of the coma is sampled each time. They will note phase angle and elongation for every frame so that geometry does not sneak into a claim. If the dust slope walks in step with a water rise, we will know to assign some of the brightening to grains as well as to molecules. Rotation becomes a nightly challenge and a gift. If Mars or the weeks around perihelion nudged the spin, the period we thought we saw in early autumn may need a small correction. Photometric modulations can reveal the new beat. Once a stable period is in hand, observers will phase fold both brightness and spectral line strengths. A waterline that swells predictably at a specific phase will point to a vent that is tied to a terrain feature. A carbon dioxide line that throbs at a different phase will suggest a second patch with a different pantry. The nucleus will not let us see its shape. It can still let us read its clock. Radio ears will listen too, if only to close a door with data. Arrays that hunt for pulsars and galaxies can turn their dishes toward the comet and search for narrowband tones that no molecule makes. The expected result is silence. That silence will not be dramatic on screen. It will be useful in the ledger. It will let everyone say with more confidence that the lights we see are from sunlight and chemistry, not from transmitters. Even nulls have narrative power when they cut a path for the story that remains. Coordinated timing will be the secret engine of this chapter. Observatories at different longitudes will pass the object hand to hand so that a single rotation can be covered without large gaps. Amateurs with small prisms will contribute low-resolution spectra that fill in where big telescopes cannot aim that night. Coronagraph teams will share their last frames, so the handoff from solar sketch to night sky measure is clean. Planetarium software will set phase angles and show which nights favor forward scattering so that dust claims do not run ahead of geometry. One possibility is that the first week brings exactly what the layered jar predicted. Water lines lift from whisper to presence. Carbon dioxide remains strong but not singular. Residuals shrink when thrust terms based on observed production are added to the fit. A competing view suggests that the spectra looks stubbornly similar to August. Carbon dioxide still leads by a wide margin. Water barely grows. Residuals are modest and align without fuss. It remains uncertain which picture will greet us, but the discipline of the program is the same in either case. Measure, phase fold, compare to the ledger, cross out what failed. Underline what held. Reorientation of the through line. We left the glare with sketches and expectations. We return with clocks, lines, and positions, and we let them decide which jar earns the center of the table. Begin with a map spread across a winter desk. Colored threads mark the passes already logged. Mars in early October, perihelion in late October. A quiet sweep that will place Venus, Earth, and later Jupiter on distant calendar squares. To an eye trained on story, the threads look arranged. Encounters fall into a sequence that suggests itinerary rather than accident. Now that December has returned our instruments to the sky, this is the right moment to ask the hardest easy question. When does a pattern become a plan? Start with what the data can answer in plain terms. Orbital elements after the December fit tell us inclination near the planetary plane, but retrograde. That geometry increases the number of worlds that the object passes within conversational distance. It does so without implying choice. Surveys also spend more time sweeping the planetary plane than high latitudes. That bias means that interstellar visitors skimming the plane are the ones we tend to notice. Selection effects do not erase a pattern, they do soften its claim on our attention. Next comes the base rate trap. Imagine a sky where thousands of visitors arrive over a very long time. Most will pass far from any world we care about. A few will slice the plane in just the right way to flirt with one or more planets. We do not remember the many dull tracks. We remember the few that nick the stage. The danger is to build meaning from salience. The set of all possible random paths includes sequences that look mission-like. The question is not whether this sequence looks tidy. The question is whether the measured forces demand a designer. Non-gravitational terms are the first judge to call. If the December residuals fall into place when we include thrust consistent with observed outgassing, then the motion is explained by chemistry and sunlight. A path that threads opportunities can be the child of luck and of where our telescopes spend their nights. If the residuals refuse to align, if the direction of the acceleration points in ways that make no sense for any vent geometry, then the floor shifts. At that point, the hypothesis bank opens its strict jars. One asks for hidden dust momentum, another asks for wrong mass assumptions. Only after those jars stay light do the shelves for the extraordinary come down from the wall. Rotation is the second judge. When the light curve yields a period, and when that period lines up with repeating features in the coma, thrust vectors can be predicted for each visit of a hot spot to morning. If the orbit model improves when those vectors are applied, we have a natural system mimicking intention by virtue of terrain and spin. If the model worsens, or if a steady offset remains after all reasonable vents are counted, we write that number in ink and begin to look for explanations that neither a comet nor a dust sheet can provide. There is room for wonder within the boundaries of caution. A sequence that takes a traveller near 4 major worlds in one season is a spectacle even when devoid of will. It hands scientists windows for observation. It hands storytellers frames full of motion. We can celebrate that luck without asking more of the sky than it is prepared to give. One possibility is that when January closes the book on the outbound leg near Venus and Earth, the tally of positions and spectra will show a natural body that wandered through our crowded plane and earned our attention by doing nothing more than being itself. A competing view suggests that a persistent misfit will survive careful modelling and force the question of to intent back onto the table. It remains uncertain which ledger will tot up the larger sum. Evidence is limited, but one inference is solid. If a misfit remains, it will be small in absolute scale, because the track so far is well captured by gravity and gentle breath. Listen for the argument that tries to sneak in backward. It will say the pattern looks like a plan, therefore it is a plan. Therefore any fit that uses vents is a rationalization. That sequence is poetry, not proof. Proof begins with numbers that fail to march with ordinary physics. Poetry begins with how a thread looks when you step back. We are allowed to love the poetry. We are not allowed to let it grade the exam. The last scene of this act belongs to patience again. Earth-based eyes will follow the object through the winter, then let it fade into the long outbound. If nothing refuses to fit, we will write the name on a list that is small but growing and file this case under natural variety. If something refuses to fit, we will say so in plain language and invite as many eyes as possible to try to break the claim. Either outcome honors the rule that patterns are invitations to measure, not verdicts that precede the math. Begin with a backyard under a dark sky, a mount hums, a camera cools, a laptop shows a rectangle that crawls with stars. This is not a prop in a romance about astronomy. It is the front line of modern discovery. Networks of small telescopes now contribute positions, light curves, and even low-resolution spectra that professionals respect when the method is clean. During a season shaped by glare and suspense, these backyards and school rooftops and small observatories become the connective tissue between large scheduled campaigns. Their strength is not in drama. Their strength is in repetition and in the simple courage to post data with timestamps and calibration notes. Signal and noise arrive in the same flood. A sharp frame of a changing coma can travel beside a stacked image that mistakes a faint galaxy for a jet. A careful light curve built on standard stars can sit one click away from a brightness claim based only on a camera's autoscale. The cure is not gatekeeping. The cure is hygiene, plate solving each image so that sky coordinates are known, recording elongation and phase angle for every session, posting single frames alongside stacks so that features can be verified, including a short note about filters and exposure times. These habits turn a forum thread into a ledger that others can audit. Leaks will appear. They always do when eyes are hungry and official releases are slow. Some leaks will be real but early, a copy of a figure that a team meant to show next week. Some will be misattributed images from a different instrument or a different comet. Some will be creations of wishful thinking or of reckless editing. The defense looks boring and it works. Ask for provenance. Ask for instrument name and for the clock. Ask whether the geometry on that date allowed such a view. If the answers do not come, file the leak under theatre and return to the sky. There is a joy in seeing amateurs and professionals weave a single cloth. A small telescope can catch a short brightness spike that a large facility missed because of weather. A large facility can then return the next night with a spectrograph that shows which molecules rode the spike. An amateur prism can show a dust-dominated flare and warn the community that any perceived chemistry change that night needs extra care in subtraction. A professional ephemeris update can nudge backyard mounts to the exact line where a faint head will rise above suburban glow. Each side can sharpen the other when pride yields to practice. Open tools keep the whole effort honest. JPL Horizons is free. Plate solving services are free. Many reduction scripts are shared by their authors without fee. A simple public spreadsheet can collect times, filters, and brightness values from dozens of sites. That sheet can be sorted by date and by phase angle. Patterns that look like fireworks often soften into geometry once the columns sit side by side. If a real outburst remains after those checks, it will stand taller for having survived them. The story gets better when the noise is sifted away by the people who would most love to be fooled. One possibility is that early December triggers a rush of uploads that mix clean measures with spectacular errors. A competing view suggests that months of practice during the approach will have tuned the community toward restraint. It remains uncertain which way the first week will lean. Evidence is limited, but one inference is durable. When respected amateurs post both successes and failures, the culture tilts toward truth. A note that says, "Clouds ruin the last hour," does more for trust than a perfect curve that hides a bad frame. Data rights and credit matter. Professionals who plan target of opportunity time on large telescopes must report through institutions. Amateurs who beat a team to a discovery deserve a line of gratitude and a citation where possible. This is not only courtesy, it is part of the immune system that pushes rumor to the margins. People who are seen and credited are less likely to cultivate secret channels for attention. People who know their work will be read are more likely to include context that saves others time. The discipline of open data protects wonder from corrosion. It lets a viewer watch a plot grow over nights and feel the patience that science demands. It lets a filmmaker show the same plot and keep the thrill because the beats are real. When Mars posts a curve in measured tones, an amateur with a small spectrograph can echo its shape from a backyard and close the loop between worlds. That is the new face of observation. Not a single stadium with a single loudspeaker, a choir that learns the song and holds the notes even when the loudest instruments must rest. The next part will gather what we have learned and what remains unsettled. It will mark which jars in the hypothesis bank have filled, which are still empty, and which now sit heavier because of a winter's worth of lines and points. Then we will hand the story back to the sky, which will keep moving long after our closing credits. Begin by laying the jars from our hypothesis bank across a clean table. Each has a slip of paper inside, some with fresh ink, some still blank. The first jar, the natural carbon dioxide-driven comet, now carries real weight. Webb saw a dominant carbon dioxide voice in late summer. Mars has likely added disciplined checks on that dominance through October spectra. Coronagraph sketches have hinted at survival rather than catastrophe. Nothing so far forces chemistry beyond sunlight and ice. This jar is not full, but it is heavy enough that any competing idea must meet it on the field of measurements. The second jar, the layered nucleus with a thermal bottleneck, has picked up a cautious note. If Mars glimpsed even a modest rise in water, that leans toward layers that wake slowly. If Mars did not, the test only moved to December. The honest entry on the slip reads that the prediction is still pending. Water should lift after perihelion if layers are real. If December gives that lift, the jar moves to the front. If December does not, the jar remains on the shelf as a minority explanation. The third jar, Episodic crust failure with pocket outbursts carries a handful of small pebbles. Amateur light curves recorded ripples that may map to rotation. Mars may have seen short spikes in carbon dioxide or in a trace line. Coronagraphs did not show a runaway bloom, which argues for punctuation rather than drama. The ledger entry says that outbursts are likely part of the mix, as they are for many comets, but they have not seized the story. They are a texture, not a thesis. The fourth jar, apparent control from repeatable jets, holds a clean diagram rather than a verdict. December light curves will either lock a rotation period or they will not. If they do, thrust directions anchored to terrain can be tested against non-gravitational residuals. Early fits that include a simple thrust term are already a small win for the natural picture. If phase-locked residuals appear, this jar earns a bright sticker that says order without intent, which is exactly the sort of order that icy rubble can make when the sun sets a rhythm. The fifth jar, the carbon-rich through-and-through body, sits across from the layered jar like a polite rival. Its prediction is simple. Ratios will change little across the season. If December spectra echo August with only a small water lift, this jar gains much. If the lift is strong and persistent, the jar loses ground. Either way, the slip inside will carry numbers, not adjectives. The sixth jar, hybrid artifact, still looks theatrical on an evidence table that prefers paperwork, no structured radio tones. No acceleration vectors that defy any vent geometry, no spectral features that beg for a factory. The rules of the jar asked for a smoking gun. None has arrived. The slip reads that this path remains open in principle, yet empty in practice. The seventh jar, new physics, remains empty by design. Gravity works, radiation pressure works, gas thrust works. If a residual survives that cannot be eaten by any of these, the pebble will drop with ceremony. Until then, the lid stays on. Positions and dates now join the jars to form a tidy ledger. We know the discovery trail. We know the early orbital solution that proved an interstellar origin. We know the Mars geometry that created a bridge during Earth glare. We know perihelion near 1.4 astronomical units. We know that risk to Earth was never a character in this film. We know that coronagraphs can sketch survival and hint at stress, but cannot judge chemistry. We know the December return of large mirrors will either change a ratio or not. These are sturdy posts that hold the tent. What we do not know has also narrowed. We do not yet know whether water has truly found its voice after heat has crept inward. We do not yet know the rotation period with the confidence needed to phase fold thrust. We do not yet know the mass, because that will fall out of dynamics only after non-gravitational terms stabilize. We do not yet know whether dust momentum has played a larger role than gas in any single spike. These are not vague holes. They are targets for specific measurements already in motion. Reorientation of the through line. Known on one side is now a scaffold of dates, chemistry snapshots, and safe geometry. Unknown on the other side is a short list of tests that can be answered with lines and positions rather than with moods. The ledger is not a finale. It is a map that keeps us honest as the traveller moves on. The final act will place that map against the night and ask for one more thing from the audience. Not belief, not doubt. Only the discipline to let numbers carry the last beats of a story that was always about light, time, and patience. Begin with a sound you cannot hear. Frost turns to gas in sunlight. Molecules rush outward. A nucleus takes a breath you cannot see and receives a nudge you cannot feel. The push is tiny. The push is enough. Weeks later, a plot on a screen shows that the point of light arrived a hair's breadth off a gravity-only path. Somewhere far away, inside that glow, pits and ledges have set a rhythm. Somewhere closer, on our hills and domes, a row of mirrors and prisms have kept the beat. We started with an eerie coincidence. A Mars flyby for an interstellar traveller and a quiet meeting of earthly leaders that shared a calendar square. We named the optics, then set them aside. We walked back to receipts, a designation that put 3I in front of a survey name, an orbit that refused to close, a velocity that made sense for a wanderer from the spaces between stars, a Hubble upper, a limit on size that kept mass honest, a Webb spectrum that flipped expectations and made carbon dioxide the first singer to step to the microphone, a week at Mars that turned an Earth blackout into a bridge, a solar sketch that traced survival, a winter dome sliding open. Along the way, we built a bank of hypotheses and we put predictions on glass. We promise not to let poetry grade the exam. We learn to love anti-tales by seeing them for what they are, the bright edges of dust sheets seen nearly edge-on, not messages, only geometry. We practice the small rituals that keep a crowd honest. Check elongation, check phase angle, plate solve, ask for single frames when a stack looks theatrical, pair pictures with spectra so that dust and gas cannot trade clothes without being caught. The film never needed an extraordinary claim to be extraordinary. It needed a traveller that spoke with a different chemical accent. It needed a path that tipped its hat to Mars, to the sun, and to the patience of December. It needed a rule that science keeps at its core. Make a bet with the calendar and let the sky answer. One possibility is that the layered nucleus jar wins the centerpiece. Water rises into a clear second voice, non-gravitational terms locked to thrust implied by gas. The cadence of jets matches a new rotation period, and the elegant mimicry of control appears without intent. A competing view is that the carbon-rich jar holds, water stays polite, carbon dioxide keeps the melody. The path stays smooth when thrust is added to gravity. It remains uncertain which tune will play loudest on the final stack of spectra. Evidence is limited until the last measures arrive, but the stage has been set with rules and clocks, not with wishes. So what is left for a viewer to hold after the credits? Hold the comfort that Earth was never at risk. Hold the wonder that chemistry can be alien in the literal sense and still be ours to measure. Hold the discipline that refuses to trade. Silence for rumour when the sun forces our instruments to look away. Hold the joy that amateurs and professionals can weave a single fabric from backyards and mountaintops, from old spacecraft over Mars, and from golden mirrors that live in cold space. If you step outside on a clear night and find the band of the Milky Way, you can feel how wide the sample will one day become. Today, our ledger holds a slender list, one object that flickered and left arguments, one that acted like a comet from a cousin cloud, one that smells of carbon dioxide and asks us to be patient. Tomorrow, or the day after, more visitors will blow through our rooms of light. Each will arrive with a different pantry and a different spin. Each will sharpen the rules we wrote in pencil for this story. None will care about our moods. All will respond to our patience. The sky writes in patience. So we learn to read that script. We watch without panic. We doubt without cynicism. We measure without haste. We let wonder walk beside rigor, and we let rigor carry wonder across the parts of the river where rumor would rather jump. If you have stayed to the end, you already know the last line. The universe is stranger and more generous than our first guesses. It gives us visitors that ask good questions. It gives us tools that can answer slowly and well.